Hello students, in the last lesson we learned about the three types of compressor stator casings and the three ways of connecting the stator blades to the casing. Today we will learn about the compressor anti-surge system. Compressor surge is a problem that multi-stage axial flow compressors always have to face. It can be seen from the compressor flow characteristics that when the compressor speed is kept unchanged and the airflow entering the compressor is continuously reduced, the compressor will enter an unstable working state at a certain flow point. We connect the points where the compressor enters unstable operation at different speeds with lines to get the unstable working line of the compressor. This unstable working line is the surge line of the compressor. When the compressor enters the left side of the surge line, the compressor will oscillate along the axis with low frequency and high amplitude. This is the surge of the compressor. Surge will affect the efficiency of the compressor and, in severe cases, it can cause the compressor blades to break. So when the compressor surges, how to eliminate the surge? This is the anti-surge system of the compressor we are going to learn today. In order to improve the working characteristics of the compressor and expand the stable working range, anti-surge devices are installed on modern high compression ratio axial flow compressors. According to their structural forms, they can be divided into bleed mechanism, multi-stage, adjustable stator blades, casing treatment, double rotor or three-rotor compressor. Let's learn about the bleed mechanism first. The air bleed mechanism of the compressor includes three different types of devices: bleed valve, bleed belt, and bleed window. As shown in the figure, the bleed valve mechanism is generally composed of several bleed valves and control elements. It is operated by hydraulic or pneumatic actuators. When the compressor needs to bleed, the high-pressure air that fills the control element will flow back, and the bleed valve will automatically open under the action of the high-pressure airflow to release the airflow. When the compressor needs to stop bleed, the high-pressure air fills the actuator and blocks the bleed valve, stopping the bleed. The figure shows the bleed belt mechanism. It primarily consists of a bleed belt, bleed holes, an actuator, and control elements. The bleed holes are located circumferentially outside a stage casing at the center rear portion of the compressor and are secured by an elastic steel bleed belt. The bleed belt is operated by the actuator. When the bleed belt is relaxed, air is discharged through the bleed holes, reducing the airflow into the rear stages of the compressor. When the bleed belt is tightened, bleed stops. The bleed window bleed mechanism is currently a common anti-surge method for high bypass ratio turbofan engines. It is generally used to bleed air at the outlet of the low-pressure compressor to reduce the airflow entering the high-pressure compressor. This mechanism consists of an annular bleed window, a bleed sealing ring, an actuator, and a control element. Next, students can think about how these air bleed mechanisms eliminate compressed air surge. In fact, the bleed mechanism is to release air from the middle stage of the compressor and change the absolute velocity at the impeller inlet by increasing the airflow, thereby changing the magnitude and direction of the relative velocity, reducing the angle of attack, solving the problem of airflow separation, and achieving the purpose of anti-surge. However, bleed air will also reduce the efficiency of the engine. Another measure to prevent compressor surge is to use multi-stage adjustable stator blades in the compressor stator. The multi-stage adjustable stator blades are composed of rotatable stator blades, rocker arms, linkage rings, crankshafts, actuators, and controllers. When the compressor is operating in a non-design state, the multi-stage adjustable stator blades change the direction of the absolute velocity at the inlet of the working impeller by changing the angle of the stator blades, that is, changing the pre-swirl amount, thereby changing the direction of the relative velocity at the inlet of the working impeller to reduce the angle of attack and achieve the purpose of anti-surge. Most modern advanced engines use multi-stage adjustable stator blades to prevent compressor surge. The third method to prevent compressor surge is casing treatment, which is to process ring grooves, inclined grooves, or install honeycomb structure rings on the inner wall of the casing, and the casing has such structural measures. As shown in the figure, the fan processing casing of the RD-33 engine is composed of a groove on the casing with an annular cavity behind the groove. When a stall mass is generated at the tip of the blade due to the pressure difference, the shutters will suck the low-speed stall mass into the annular cavity behind it, and after being processed, it will flow back to the airflow channel, which will suppress the airflow separation at the tip of the blade, thereby improving the surge margin of the compressor. The last method to prevent compressor surge is the twin rotor or triple rotor engine. The twin rotor or triple rotor engine changes the rotational speed, that is, changes the tangential speed of the compressor impeller to change the direction of the relative speed at the inlet of the working impeller so as to reduce the angle of attack and achieve the purpose of preventing surge. The surge of the compressor is generally caused by working at a low conversion speed, so the surge usually caused is the front surge and rear vortex type surge. For a twin rotor engine, in order to solve the separation at the back of the blade, the speed should be reduced when the absolute inlet speed remains unchanged, so a low pressure compressor is used. For the latter stages, in order to solve the separation at the blade basin, the speed should be increased when the absolute inlet speed remains unchanged, so a high-pressure compressor is used. This is impossible for a single rotor engine, so a twin rotor engine is used. Students, in this class, we have learned 4 anti-surge measures for compressors and the anti-surge principles of each measure. I hope that students will review carefully after class, familiarize themselves with each anti-surge measure and anti-surge principle, and learn from it. Thank you, everyone.